This video will cover how to natively customize and organize Vim for effective editing. We're going to cover configuration basics, syntax and highlighting, file types, autoload scripts, Vim native compiling, global and file-specific plugins, packages, and portability. Now, let's get this party started. Yo, it's been 2 years since I gave that last talk on Vim, and I regret so much not doing more of them because they were so much fun. Today I'm going to be talking about Vim organization. In particular, I'll teach you how to use Vim's native organizational mechanisms and configuration mechanisms to make Vim easier to use and how it should be used in the native way. A lot of times I see beginners do too much of beefing up their Vim RCs until maintenance is no longer manageable, or just downloading a shit ton of plugins until you don't even know what's doing what. In this talk, I'm going to be talking about how you can utilize Vim's native configuration capabilities to make this whole experience a lot more smooth. So to begin with, I thought it would be cool to talk about initialization, because if we understand what is happening behind the scenes when you open Vim, then I think everything else will also start to make sense. And in each of these slides, I'll be showing off a lot of detail for those who are more detail-oriented, but it's perfectly fine if you don't want to read all of it. All that's important is you kind of look at what's highlighted or what's made bold, because those are the important points. And the important point of this slide is on the left. When you first open Vim, two things happen. And in this slide, I'm talking about the first thing. And that first thing is a bunch of X commands are executed. So your next question might be, what is an X command? Well, if you are ever running Vim and you typed colon and you did something like a search and replace, you're executing an X command. And it's called X command because the original V was based off the X line editor, which is called X, and hence why they're called X commands. Anyway, let's talk about initialization. And before jumping into it, note the two purple environment variables. They're $vim and $vimruntime, or Vim runtime. Let's examine those really quickly. If I open up a new terminal, and by the way, this is a fresh computer that I just bought, there's no Vim configuration files defined anywhere, which is perfect for this talk and perfect for showing Vim's native capabilities. Anyway, if I look at the Vim environment variable or the Vim runtime environment variable, I'll see that nothing's defined. Yet, if I open Vim and I look at the the environment variable Vim and the Vim runtime environment variable, you'll see that they're defined. So what's going on over here? Also note that for this presentation, everything I'll be talking about will be focused towards Unix systems. And that only makes a difference if you're following the folder structure for all the runtimes. Otherwise, everything else is the same. But in this case, when I look at my details of compilation for this instantiation of Vim, you can see that if I go to the bottom, we see that there's a fallback option for what this environment variable is defined. So even though my shell hasn't defined it, Vim has it defined already. And this definition is done on compilation. So if you're using any Unix platform, your default Vim and Vim runtime environment variables will be as listed here or on the slide. So anyway, that's something cool to keep in mind, because you'll notice that a lot of runtimes are based off these different variables. Anyway, how does initialization work? Well, most people just know if I have a Vim RC, it gets sourced, and that's usually located in your home directory, and that's the end of it. Actually, a bunch of other stuff can happen too. For example, most people don't know, but if there's a system Vim RC defined, which is usually defined by your system administrator, and that's why you usually won't have one, if that's defined, it will load that first, and then it will load any of the following user Vim RC configurations. But it will only load the first one found. So what do I mean by that? There's a prioritization order here. And again, none of this really matters. You're only going to really use your user-defined vimrc, but if you're looking to expand into an organization, you want all your employees to have like some set of default configurations, this ordering might be useful to understand. Also, the last option is important to understand. But anyway, let's look at how we can utilize some of these. The first cool thing is there's an environment variable called vim_init. What this means is if you have an environment variable with a bunch of X commands and you open up Vim with that environment variable defined, then your user vimrc won't even get sourced. And instead, that one will be sourced. And I'll stop talking and show you how that works. Basically, if I set a vim_init environment variable, let's make it print out hey, and I open Vim, guess what it does? It prints out hey. Now the next thing you might wonder is, what if I have both, right? What am I talking about in terms of prioritization orders? Well, we can define our own vimrc. In this case, I'm going to type echo, hey, this is vimrc, and I'll save that, and I open up Vim again with that environment variable. You'll see that the vimrc environment or vimrc command isn't actually executed. And that's because there's a prioritization. Of course, if I remove this environment variable, then guess what will actually get executed? The hey, this is vimrc echo command. So all I wanted to show over there is that, or show here, is that there indeed is a ordering to the Vim user configurations. Okay, cool. Initialization. That should make sense, right? It's just a bunch of X commands that get executed, and usually it's a user-defined vimrc. I think most people kind of already knew that. They just weren't aware of these like minute details that are also cool. That's the first thing that happens. Second thing, which is going to be the crux of this talk, is that a bunch of packages and plugins are loaded. Oh, and by the way, before getting to that, what if I don't want to load anything? Well, you can just type in vim-u none or vim-u no rc to mean I don't want any plugins or Vim configuration variables set, or I just don't want any Vim configuration settings set for the latter. So what is a plugin and what are packages, which is the next thing that happens when Vim gets executed, that these things get loaded? Well, without being too complicated, basically what happens is plugins are loaded from plugin/**/**.vim, and this is usually home/.vim/plugin/**/**.vim, and then usually this is and then packages are loaded, and then blah 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 blah. What the hell am I talking about? Don't worry, this is exactly how I felt when I first read all this documentation, because it's so confusing. Or it can be confusing if you don't know where to look. So what the hell is runtime path? What's packages? What's plugins? And why the fuck is this /pack/ whatever the hell it is so damn long? Don't worry, I'm going to clarify all of this. That's exactly what this talk is meant to do. So I want you to forget about everything you see in this slide, unless you already know about it if you're an intermediate or advanced user. And we're going to focus on something else. We're just going to focus on the runtime path, because I think this is the most important thing to understand. And if you understand this, you'll understand how all the other configuration goodies work behind the scenes. Basically, a runtime path is nothing but a list of directories which will be searched for runtime files. And basically, each of these directories has a certain structure for how these runtime files are sourced and or allocated or loaded or whatever. So whenever you're running Vim, right, sometimes you'll see pretty colors. That's because you have syntax highlighting. And Vim system runtime defaults configure all of that in a bunch of scripts in your system runtime folder under the syntax folder. Similarly, you have a bunch of global plugins that are included by default, or a bunch of scripts, a bunch of file type detection settings. All of that stuff that makes Vim so magical is because of the system Vim runtime folder. And we're going to examine each of these in detail. And what's blue, I will give a concrete, practical example that you can follow along with so you know exactly how to use them without me just blurting out all these terms and terminology without actually showing how to use them. So stay tuned, because that's going to come real quick. Anyway, for now, all we really want to know is this is a list of directories which will be searched for runtime files. And so what should I remember here? Well, basically there's 5 directories. And you can ignore everything except 1 and 3 for now, because those are the important ones. Specifically, there's some sort of ordering applied here to which all these runtime files are executed. And the first one is the user Vim runtime folder. And so this will have this kind of structure should you choose to define it. Otherwise, it's going to be blank if you don't have anything, like for my case, because I have a new computer. But basically, when Vim is loading any kind of scripts or when it's opened, yada yada, it will look in a particular order to execute all these runtimes, depending on the context. And the first thing it will look for is the user-defined runtime, which is usually defined in user home. Of course, you can change this, but by default, as you can see in the bottom, it's in the home directory /.vim. After that, some system administrator runtime is actually loaded. You don't need to worry about that. And then number 3 is really important. The system Vim runtimes are executed. And this is where all the system defaults are located. We'll show you how that works in a bit. But anyway, what you have to remember here, user runtime is pretty important, and that's where all your configuration will be located. So you might want to create your own environment variable that points to home/.vim if that's where you want to put your user runtime environment variable. And then there's 4 and 5. We'll look into that later. But let's look a bit more at this ordering. How the hell does that work? So to look at the ordering, I want to do something really quickly. I want to open up Vim and first look at what Vim has to say about runtime path. And you can do that with the help command. Specifically, just type runtime path or RTP, and it'll show you a bunch of information on how all this works. We can exit out of that now. We can also look at our runtime path by typing set runtime path with a question mark. And you can see what my runtime path is. And you'll see that it accurately reflects what I actually just wrote on the slide. So what I want to do now is, and this is a quick example you can follow along, I want to see what order these runtime path directories are actually executed. So one thing I can do is I can quickly print this out without even having to go into insert mode by typing the expression register, which is the quotation mark =, and then I want to say spit out the contents of this runtime path option, and then P for paste, and it's pasted on my screen. And now what I want to do is I want to create a really simple bash script that iterates over all of these folders, creates a simple plugin directory that echoes out what folder that is, and then open up Vim with these new simple plugins defined so I see the ordering. Hopefully that makes sense. If it doesn't, just rewind and repeat what I just said. Now, to do that, I'm going to quickly replace these commas with spaces so I can iterate over them in Bash. And then I'm going to copy it to my system clipboard. In this case, I'm going to use the plus register because I'm on OS X, and to integrate with your local register, you have to use the unnamed register or the plus register. So that got copied to my local clipboard. If you want to know more about clipboards, you can look at help clipboard, and you can also, to make this your default unnamed clipboard, make clipboard = unnamed. So now whenever I yank something, it actually goes immediately to my register, so you don't have to deal with typing the damn register explicitly. But anyway, the copying stuff doesn't matter because at the end, I'm going to show you the best way to do local clipboard synchronization using OSC 52. And to me, that is the most revolutionary thing I've ever learned about Vim. I don't think revolutionary is a word. I just missaid that. Fuck it. We're going to continue with the example. So I'm going to exit out of this buffer, and I'm going to say that I want to loop over every folder that I just copied And for all of these folders, what am I going to do? I'm going to create a little directory for putting a simple plugin in. I'll call it test. And in that little simple plugin folder, I'm going to create a script that does this. It will echo out a actual representation of what that folder is. And I have to make the quotation backslashed so that we can actually define the echo command within the Vim script, if that makes sense. And then I'm going to end that up. And then I'll add the folder /plugin/test/test.vim. So you don't really need to follow along here. All that I'm doing is I'm creating a simple script for echoing the folder that's being executed. And then once that's done, we can show you this in action. If I hit Vim, guess what? It tells me which of these are executed in which order. And you'll note that this is exactly the same ordering I put on the slides. So the point here is that there's an ordering to your runtimes, and that can be useful. We'll see why later. So that's runtimes. Now let's look at the components. Look at the components on the right. I'm going to go over examples for each of the ones highlighted in blue. So first one, syntax. Enabling customized syntax highlighting. So one might ask, what is syntax? Because a lot of people actually get this confused with the color. A great analogy here is when you write an HTML file, the HTML file actually does the semantics. It doesn't do the coloring. The CSS does the coloring. So in Vim, it's the same thing where the syntax does the actual semantics and the coloring is done by highlights. So basically, when you invoke this set syntax equals XXX command, then a syntax file named XXX will get sourced from the runtime path. And usually an auto command does this if the file type can be inferred. So let's quickly look at how this works by default. If I open up Vim, I can go into the Vim runtime and I can see that it follows the structure I showed you. And I'll go into the syntax folder, and you can see there's a bunch of predefined files for which syntaxes are defined, or syntax settings are defined. And there's a main one called syntax.vim. And I want you to pay attention to this one line, which is runtime syntax test synload.vim. Every time you execute a syntax enable or syntax on, this is what gets sourced. And if you don't know what those commands are, I'll show you in a second. But anyway, this loads these syntax auto commands that allow the highlighting to get pieced together with the syntax. And just to go on an aside here, if you remember my last talk, I talked about the GF mapping, which allows you to go into a file. I'll show you how that works right now with raw Vim. Basically, that works by having a path attribute that includes whatever file you're trying to go into. In my case, my path actually doesn't have this folder. So I'm going to add to it. And I'm going to say set path plus equal Vim runtime. And now if I do a GF, I'm inside the file. And if you don't want to do this for every folder you want to actually use these cool mappings or commands for, you can just set your path to include the current directory and all directories relative to your current working directory traversing downwards. You can look this up on your own time, but it's a pretty helpful option to have by default, I would say. Anyway, all I wanted to show you is that the system runtime in Vim configures a basic sourcing of all files in the syntax folder, or not all files, but if, for example, you're using a Go file, it will source the syntax /go.vim file. So as an example, if I go to a Go file or create a new one, if I do an import xxx or an int yyyy, we see pretty colors. And why do we see pretty colors is because syntax is on. If we put it off, it's black and white. If we turn it on again, we get colors. If we turn it off, we get black and white. And another thing you can use is syntax enable. So one might ask, what's the difference between those two? Well, the difference is the enable allows you to keep your current color schemes. So what do I mean by that? Well, basically the way this works, right, is there's syntax groups and highlight groups. Remember I said there's syntax and highlighting. Basically the way it works is you define a syntax group that gets linked to a highlight group, and the highlight group defines the colors. So as a quick example, let me change the color of this import. And I can do that by actually modifying the highlight group that it's applied to. In this case, it's using a universal highlight group called statement. You can worry about what all these mean later, but basically if I change this to use a different foreground color, it becomes red. And you can look at all the highlight groups if you're really interested by just typing hi. And now if I do syntax enable, the color is kept. But if I do a syntax on, it's set to the defaults. So that's the difference between syntax on and syntax enable. Anyway, I just wanted to show you how all of that works behind the scenes. And so the next question you might ask is, why should I care? Well, you should care for two reasons. One, because maybe you don't like the default syntax settings and you want to create your own or override existing ones. Or two, maybe there is no syntax defined for certain file types, or you don't have predefined syntax settings that you would like to have for a certain file. Which brings me to the first practical example. And what we're going to do here is we are going to configure our own syntax settings for a file that has no predefined syntax settings. In this case, we're going to look at the SSH known host file. If you don't know what that is, if I go to my .ssh repository or folder, you can see I don't have it defined right now. But if I go to some Git repo and do a git pull, it will ask if I can continue connecting because the authenticity of the host can't be established. And I'll say yes. And then all of a sudden, I have a known host file defined. And the reason that happens is because the known host is usually used as a way of helping clients authenticate to servers by virtue of saving their public keys when the client says that that host can be trusted. So let's open that up. And when I open that up, you'll notice that there's no syntax highlighting. So why is that? Is my syntax turned off? No, it should be turned on. Let me just double check that by looking at the global syntax variable that usually indicates whether it's on or off. It's 1, which means it's on. So what gives? Well, what gives is the fact that this has no syntax file linked to it. So what we can do is we can define our own. So I'm actually just going to open up the directory with the user vim runtimes, which for me is home/.vim, and for you is probably the same. And you can see over here, I don't have anything like the system vim runtime has. And the reason is because I haven't defined any user configuration. The only two things I have are the after and plugin folder, and that was just created for my simple test script I showed you a couple minutes ago. So what I can do is I can define my own syntax folder, and I can go into it, and I can create a file that represents custom syntax configuration for an SSH known host file. So let's call that SSH known host.vim. And in here, I'm going to quickly create some syntax settings so that this stuff can look pretty and shit. So the way I'll do that is I'll start by defining a syntax group. And the details here, don't worry about it. You can just look it up on your own time. It can be kind of confusing. All I want you to know is you can do this if you want to. But basically, what you do is you create a regex that matches to a syntax group you predefine. In this case, I'll call it SSH known host pub key to first match for example, the public key we see at the end right here. So with this, I'm going to figure out how to create a regex that allows me to match this. And in my case, I usually am having RSA public keys placed here. And due to the nature of how RSA public keys work, the heading is encoded such that it always starts with 4 A's. So that's usually a good start. And again, these aren't really good examples to use for a production environment, for example, but they're a good way to get started. And you can iterate on like these basic settings as you go. I'm just showing you that this is possible. Anyway, I define a public key as 4 A's followed by a bunch of 0 to 9s, A to Z's, capitalized, uncapitalized, a plus sign, and a slash sign. And I have one or more of these. And then it's padded with an equal sign, which is usually 0 to 2 times repeated. So that's my first regex. I'm just double checking that that looks good. It looks good to me. Next thing we do, right, because I said there's the actual syntax groups and the highlight groups. The highlight groups give it color. So I have to give this highlight group a link to my syntax group. And in this case, I'm going to use a highlight group called special. And again, you can see all the highlight groups by just typing hi. Next thing, I want to do another color for something else. So let's look at the algorithm. For example, SSH RSA. I can quickly define another syntax group. I'll call it SSH RSA or SSH alg. And I'll say that anything that matches SSH RSA will be part of this keyword. And then I'm going to link this to a highlight group called identifier. And then finally, let me define one more. Let's do the IPs. So if I do a syntax match, I'll call it SSH known host IP. In this case, it's a bit harder. Let's define it as a starting of a word boundary followed by a group consisting of a digit that happens 1 to 3 times, followed by a dot, followed by the end of the group, and then that group gets repeated 3 times, right, for 3 IP blocks that each have 1 to 3 numbers each. And then we'll end that with a final IP block that's also 1 to 3 numbers but has no dot, if that makes sense. And let me just double check that that looks good. It looks good to me. Next thing we can do is we define our final highlight link, and we'll link this to our SSH known host IP. I can use Control-N for auto completion, which is a great feature you should utilize too. So now we define our own syntax file. And with this, I can actually specify that my syntax is of type SSH known host. And here I clearly made a typo somewhere. I think it said identifier, and that's because I didn't link the actual highlight group to what it should be linked to, which is SSH alg. So I need to link this highlight group to SSH alg. And we'll save that, and you can see that indeed everything else was highlighted except the identifier group belonging to SSH RSA. And the reason for that is because I'm using the syntax keyword configuration. And this is a common configuration mistake people will often overlook, which is to do with keywords. And the reason this doesn't work is because this has to be a keyword. And Vim doesn't think SSH-RSA is a keyword. And guess why? Well, we can check why, and we can look at our isKeyword option. So if I do set isKeyword, notice that this matching doesn't include the dash sign. So what we can do is we can define this ourselves locally in our buffer by saying that isKeyword is equal to, and let me use the expression register to just quickly copy that while in insert mode. is keyword, and then I'll add a dash, and that should be good. Now if I save that and I reset the syntax, voila, we have highlighting. Pretty magical, right? And that was pretty simple to do. I think just the regex can be kind of tricky, so maybe learn that just on your own time. And then realizing like what groups to use, even I don't know that. But the functionality is pretty easy to learn, I would say. So one thing though to note is that if I change my buffer, suddenly the file disappeared. I must have accidentally gone to a different file. Whoops. Basically, if we change buffers and change back, the syntax highlighting is suddenly gone. And the reason for this is because there is no automatic file type to syntax inference going on, which means right now the only way we can get this to work without doing anything too customized is to set the syntax manually every time. Obviously, that's going to be a pain in the ass. So that brings me to the next point, which is file type detection. And this is another setting that you can configure. And it's composed of a lot of different parts. Basically, you just need to know that you can customize how file type detection works. I put the 4 different ways it can work at the bottom, but I won't go into too many details. Basically, there's 4 ways you can do it. The first way is you override the file type after the default detection. So you know how there's a system vim runtime? Well, that's always going to be executed first if you use this first method. And then based on whatever gets executed in the system runtime, you can choose to override that by creating a auto command in a file in a folder called ftdetect with this set file type equals file option. Or you can basically create a completely new file type after the default file type detection inference. We're going to focus on number 3, which is basically defining a file type before even the default file type detection is done. So basically with this you can say, hey, if I see a .go file, I want the file type to be .mygo or something, and I don't want the defaults to interfere with anything. That's an example for number 3 as an option. Or for example, if you want to define a new file type, I feel like putting it in one file called filetype.vim is a solid choice too. So as an example, I'm going to show you how we can use this functionality to give our known host file a file type. So let's go back to our terminal. And what I can do now is I can create a file type folder inside of our user vim runtime. And to do that with option 3, all I have to do is create a filetype.vim file. And in it, what I want to do is I want to say to use an auto command. And an auto command is just a command that automatically gets executed based off some events that occur. In this case, the events are if I open up a buffer or if I read a buffer and the name of whatever I'm opening or reading is called known host, then I'm going to set the file type to the custom custom file type SSH known hosts. And using this, it will also be able to link to a syntax file called SSH known hosts. So that's really simple. So now let me just show you what happens. If I reopen the SSH known host, you'll see that syntax highlighting is automatically there. And that's because we defined a file type that has the same name as the actual syntax type, and then the system automatically links the two together. So that's pretty cool. Moving on, Autoload. This one was really hard for me to understand, but it's pretty simple if you can explain it properly. Basically, if you have a super beefed up script or plugin, you don't actually want to load all of that plugin settings immediately upon opening Vim. In many cases, you only want to load the settings when you actually need to use it, right? Otherwise, why do you waste all your system resources loading up all that junk? And basically, the semantics of this are pretty particular in that when you create a script in Autoload, the script function must have an explicit signature whereby its file name of whatever the script file name is, hashtag function name. And I'll show you how this works. And basically then, when you have some other plugin that calls this function, it will then look in the Autoload directory for whatever that file name in the function is, and source it, and then call function name. So what's a good use case for this? Well, I thought a cool example to do would be to create a script that automatically uploads a file to GCS when you invoke this command. And I actually think this script can be pretty practical. So in this example, we're going to create a script that uploads whatever file you're editing to GCS, and GCS is Google Cloud Storage. It's just a object storage mechanism that is done by GCP. So what you can do is I'm going to open up our user runtime again. And in here, what I'm going to do is just create that folder. You can see we've done like 3 examples so far. It's all the same pattern. You just use the directory listed in the Vim runtime that I showed you in the slide, create your script, and then it just works, right? Anyway, in this case, we create a directory called Autoload. And in Autoload, I'm going to create a file, let's call it gcp.vim. And in this file, I'm going to define a script to upload my file to GCS in a predefined bucket. And just to again illustrate how great Vim is, I'm not even going to write this script in Vim script because, one, I think it's even better, especially for newcomers, to show how easy this can be. And most people, I think, know Python, for example. I'm going to write this script in Python. And 2, I don't really know Vim script. So anyway, I don't know enough Vim script to write something super basic, so we can still utilize that. And what you can do is, first I'm going to write a simple echo command just to show that this, in fact, doesn't get called upon until you actually call the function within it. And I'm just going to say initializing Autoload plugin. And that might be the extent to my Vim script knowledge. Well, guess what? I can actually type this whole thing in Python. No problemo. I just do until pyend is found. Everything's in Python. And now I can just write some really simple Python. I'm going to use the Google Cloud Storage client, import storage, and then create a simple function. And basically this function does something really easy. You get the storage client, and then you get a bucket. In this case, I have a bucket I already set up. It's called my first name, Leeren. And I'm going to create a blob, which is just an encapsulation of a GCS object with a bunch of, file permissions or objects set. And in this blob, I'm going to call it Vim demo. And then what I'm going to do is I'm going to upload the current file. So this is where the good question is. How the hell am I going to get the current file name? Well, Vim is so cool you can actually use Python Vim modules within Vim within Python. So what I can do right now is I can use the Vim module to evaluate a Vim expression. And in this case, my expression will be expand to get the current file denoted by the %, and get the path of that file, and then enclose that with my brackets. And then at the end of this, I will just print uploaded. And then I just type py-end. And that's it. And then I just define the actual Vim script part of things. In this case, the file is called gcp.vim, so this has to be prepended with GCP. And I'll call the actual function upload. And all I got to do is run the upload function I define in Python. In this case, I'm using Python 3 because I didn't compile this Vim with Python 2. And by the way, you can check that if you type version. And you can see I don't have the Python compilation option set. I only have Python 3. Just a small thing in case you're debugging and running into the same issues. So let me just look over this script to see if it works, because live demos are pretty easy to mess up. I have the storage client, create the client object, get the bucket called Leeren, get the blob, and then upload from the file name. I think that looks good to me. So what are we trying to do here? Just to show you, I have a bucket defined here, and it's called Leeren. And if I refresh this, you'll notice that there in fact is nothing in my bucket. So let's go back. And now let's say we want to upload a file. And I don't even need to exit Vim, right? Because these are all auto-loaded. So let me just create a file to upload. And let's just upload a random file with, let's say, the sum of two numbers. Just to show you more of the expression register. I can sum this up easy by just copying it and saying equal, and then doing the expression register, Control R equal sign, and then just pasting using again Control R my unnamed register, deleting the actual carriage return and hitting enter, and I get the addition. So in case you've been using Spotlight, if you're on OS X this whole time to do your addition, this actually might be faster if you get used to it. So now let me save that file. And now, watch this. If I call GCP hashtag upload, it says initializing autoload plugin, and then it says uploaded. Is it really that magical? Was I able to write a script that uploads to GCP that quickly? Let's double check. If I go back, refresh this, guess what's there? That demo script. Bam! Simple. And in Python. In case you don't know Vim script, you can already script in Vim if you know Python. So that's pretty dope. Let's continue. And it's going to keep getting better and better, I promise. Next thing, compiler. Guess what? Vim has built-in compiler options that you can use. Basically, the way this works is when you're invoking the compiler XXX command, you'll get compiler-specific options from a xxx.vim file that are sourced. And the main thing that happens is a make PRG option is defined, which defines like the build tool you use, and also an error format is defined. And basically this error format is used to figure out what the errors are and how to translate them so that Vim can natively navigate to your errors using the quick fix list, which I mentioned in the previous talk, in case you don't know what that is. So let's quickly look at the system defaults. If I go to Vim runtime again, and I go to compiler, I can see there's a bunch of compiler options already set here. You'll notice that we don't have any for TypeScript. And the reason I'm saying that is because the example we're going to follow along with is to build a custom compiler option for TypeScript. But before doing that, notice that Java has one. So we can use Java C to do compilation, and it has all of this predefined. So in case you're building a new terminal window to do this every time, which you can do in Vim, by the way, I just didn't show it yet, but you can literally just say, I want terminal in the bottom window, and then go to some folder with Java in it. I have one right here, and I can do Java C talk.java, and I see I have a bunch of errors. And this is for Vim 8. I just was using NeoVim and I switched back to this to see the difference. I'm still getting used to the Vim 8 version, but both Vim 8 and NeoVim, they all have terminal built in, which is super cool. Anyway, I'm just going to quit out of this. If I open up that Java file, because Vim already has a default compilation option set, I can literally just do make and then my file, which is denoted by the percentage sign. And guess what? It says nothing to be done for this file. And that's because I'm in the wrong directory. So notice that whenever you're working with Vim, you might run into some weird issues. A lot of times it's because you're not in the right directory. I can change the directory of my current window to be the head of the current file. And now notice that if I print my working directory, it's in the Java file. So now let me make that again. And again, it's not working. And now I'm kind of confused why. Nothing to be done for talk.java. Okay, we're doing live debugging at this point. What could be the issue here? The file is clearly defined right here, but nothing can be done. Aha, I think it's because there wasn't a compiler defined yet. So now, if I make, then it works. So by default, no compiler was actually set. So let me just double check that the directory didn't matter in this case, because what I just said might have been wrong. Yeah, so the directory your file was in didn't matter in that case. It matters though if your build tool is using the directory to make inferences on how to build all your files. In this case, because I was saying a specific file, mainly my current file, it didn't matter. But it could matter, so I'm glad I went over that anyway. But as you can see, usually, I think almost in every case, compilers aren't by default assumed based on the file type. But that's something you can do yourself with customized plugins, which I'll show you later. But anyway, my point here is, we can use this built-in make tool as long as we set our compiler, which I just did with compiler Java C. And the compiler option obviously has to exist. And then once that happens, you can actually go over your errors using the quick fix window. And we can open that with C open. And you can see all this stuff is defined, which is really cool. So now let's go back to our example. I often use TypeScript for some of my work. I've been doing a lot more Go recently though, and I've got to say it's way more smooth. Thank God I'm done with this. No offense to TypeScript, but the building is just, it's kind of messy. Anyway, compiling TypeScript. In this example, we want to natively integrate TypeScript's build tool, TSC, into our Vim edit compile edit cycle. And like I showed you earlier, TypeScript by default does not have any compiler options. But again, I'll show you how simple this is to do. And before doing that, let me just show you what happens when I actually build something in TypeScript. So I have a TypeScript directory right here. And in my directory, if I do tsc dot, it will do a bunch of builds. In this case, I want to specify that my project is in this directory that has the tsconfig.json, because that is necessary for TSC to infer the build options and where all the files are placed. So if I do this, I get a bunch of errors. Let me just show you that a bit more clearly. So I grep for the errors, and you see I have a bunch of errors here. Also, a weird thing about TSC is the std out is not like what is displayed, which really confused me. If anyone knows the answer to that, please let me know, because I'm really confused by that. So what I mean by that is, like, just now when I ran that build tool, right, like it looks like this. It has this format, right? But then if I get std out explicitly by piping it to grep, it's a bit different. Anyway, that's just another small detail on the side. You can forget about what I just said. Anyway, we want to do this building natively inside of Vim. At least inside of Vim non-terminal windows. So let's quickly switch to the directory of my TypeScript, which I believe is in here, right? And I'm going to quickly add to my args list all the TypeScript files. Hopefully you know about the args list from before, and that is not so nice because I don't want any of the node modules. I just want my core source files. So now we can see in our argument list are our two sourced files, and you don't need to look at the actual contents of these files. All you need to know is there's a bunch of errors defined in each of them. And basically, I want to be able to build a tool that natively builds while I'm working with TypeScript, but there is no compilation setting defined. So let's define one. So we go to the user runtime and we create, like we did always, a folder called compiler. Go to compiler, and this time we'll create a file called typescript.vim to build a TypeScript compiler. And guess what? This is so simple to do. All you have to do is set the compiler's make program to TSC, and then you have to define an error format so that it's able to translate those errors into the actual lines in which your file is located. So in this case, if you look closely, it begins with a file name, and to indicate that this is an error, we do %e capitalized, and then you see it's a file, right? Like source/demo.ts, and then we have a opening parentheses, and then we have a line number, and then we have a comma, which I must escape because a comma means something else in this context, and then we have a column number, and then basically we have a colon, and the rest is just a message. And that's it. We're done. This is a great example where if you're not doing anything fancy, you don't need to install a plugin. You can just literally define 2 lines of code, and you get all of this built in for free. So let's go to our argument list again, which has my 2 TypeScript files. And watch this. I'll make the compiler TypeScript, and because I don't need this anymore, let's make this the only window. And now if I do a make, guess what? It shows me the errors, and then it's all in the quick fix list, and we can just navigate through this using the different quick fix commands. And I can repeat this with &:, for example, and it'll even go to my other files. It's great. So that's pretty cool. The only problem though right now, right, is we had to set the compiler. That's why I was having issue with Java actually. Sometimes I forget that the compilers aren't automatically set. So that brings me to the next topic, which is file type plugins, because file type plugins are a great solution to this problem we have, which is automatic compilation or compiler setting inference. So FT plugin, if you haven't figured out yet, is basically a script that's loaded for particular file types, and it applies to your current buffer. And again, there's a bunch of system defaults defined in Vim runtime/FT plugin. By now, I think you should be able to figure out how to look at that yourself. So the next thing I want to do is I want to create a really simple file type plugin that's able to figure out the TypeScript file needs a TypeScript compiler. And then one other thing I want to do is create a mapping so that I can automatically execute this on execution of that mapping. So again, just to reiterate, I am going to create a way of automatically inferring that TypeScript files should use my new TypeScript compilation settings. Pretty simple. Hopefully that makes sense. Oh, another interesting thing I want to do. When I run make, it's really annoying that it opens this new window that says press enter or type command to continue. I don't want that. That's really annoying. I just want to automatically be in this state where I can go through my quick fix list to correct those errors. So I'll show you how to fix that too, and we'll do both of them in the plugin. So let's go back to our Vim runtime, and you know how it goes. We create a new folder for whatever it is we're trying to do. This time we're making a file type plugin. Create that directory. Go to the file type plugin directory. And in this case, we're going to create a custom script for TypeScript files. So we have to call it typescript.vim. Notice that Vim already does know that this is a TypeScript file. So to do this, there's always, like, if you talk to a Vim expert, they're going to suggest doing more options, and I suggest like looking into this more yourself. But just for the demo purposes, I'm going to make this really simple. Guess what we need to do? We got to set the compiler to TypeScript. That's 2 words. Now another thing we want to do is we want to define a mapping that automatically executes compilation. And we can define a non-recursive normal mapping. And you can do a help on that to see what that means. And basically I'm going to map this for my current buffer so that when I hit space, it's going to run make, and that's it. And that'll work. But remember, there's an annoying message. Well, what we can do is we can make this be done silently so that it doesn't display that annoying press enter to continue. And one issue with this too is that if you do this, your screen can get kind of fucked up sometimes, which means we want to redraw the screen too. So this is just, the bar is just indicating I want to separate 2 different commands, and I want to redraw the screen. And that should be good, I think. That looks good to me. So now, if we go into our buffer, let me just double check that that looks good. Buffer space silent make and redraw. That looks good to me. Oh, the exclamation mark, by the way, it means we clear the screen before redrawing. So now let's make sure that our file type is set, and of course it is, because Vim automatically does that for TypeScript. And what we can do is we can hit the space key. And I just hit the space key and nothing happened. And that's because it has not been sourced yet, because usually sourcing of file type plugins only happens when they're edited again. So what we can do is we can quickly source that file. There's actually an easy way of doing that. I think it's Filetype Detect. Oh yeah, that's what it was. Now if I hit space, guess what just happened? It was so fast you couldn't even see it. It just did exactly what I talked about. It was able to figure out all the errors without showing us that annoying screen, or at least making us have to manually hit enter to continue from that screen. So guess what? We just defined a really simple plugin that lets us compile our TypeScript by hitting space. And look at how smooth that is. That makes your workflow so much easier, and it subtracts one unnecessary terminal window. So that's cool. Now we're going to keep moving on. It just keeps getting better and better. Next thing, we're going to talk about plugins. Specifically global plugins. So just now you saw file type plugins. Next we're going to talk about global plugins. These are automatically loaded when Vim starts. And they apply to everything, not specific file types like the file type plugins. So remember I talked about having this new clipboard synchronization mechanism that will blow your mind? We're going to create a plugin for that. And I think you should pay attention here because this remains the most useful tool I've ever come across. Especially if you're working in a lot of nested SSH sessions. And unfortunately, it only applies if you have an X11 compatible terminal, or sorry, Xterm compatible terminal, but I think most people do. iTerm works great for this. But basically what OSC52 is it's an escape sequence that allows the TTY to send a signal to the actual terminal to copy over whatever contents the TTY has into your terminal. And the reason that's so significant is it means if you're SSHing into some Linux box, right, and you have OSC52 enabled, or at least this plugin which I'll show you, if you yank in that nested SSH session, it will go directly back to your local terminal, which is super cool. And again, if you find that shit lame, that's fine. Maybe you can skip this slide. But anyway, it's super dope. Next thing I'm going to do is show you how we can build that plugin. And we're going to do this live. All this shit is live. So, like we always do, let's go to our local Vim runtime. And you know what to do. We create a directory. This time it's called plugin. And, oh right, plugin's already a directory. Because remember that simple script I created? We made that test script. So here I'm going to create a new plugin. And I'm going to call this one OSC52.vim. Or actually, I'll just call it yank.vim. That's nicer. So in yank.vim, we're going to create this cool function that does an OSC52 yank. And in this function, you don't need to understand the details. You can just copy this later. It's all in the slides. What we're going to do is we're going to say let the buffer equal the result of running base64, assuming you have it in your shell, on the default unnamed register, or the 0 register, which has the contents of your latest yank. And from here, sorry, this isn't the unnamed register, but it's the register that has the latest contents of your yank. I know a lot of people are super pedantic. I hope I don't make any mistakes. If I make any mistakes, please correct me in the comments below. Anyway, we execute base64 on this register, which contains our last yanked contents. Just to show you how this works, if I just do a yank and I type register, you can see that the 0 register, in fact, does have that content. After I do that, I can substitute in my buffer to get rid of the new line, because that can be annoying, because the base64 command will automatically add a new line that might screw up the output of your paste. Anyway, we replace that with nothing. Next thing we do, and this is the OSC52 specific stuff. So basically, for the terminal to understand this escape sequence, we define the escape and then right bracket symbol, which indicates the start of the operating system command. That's what OSC stands for. So in this case, we have escape, and then we have the right bracket, and then it's number 52. That signifies the end of that command part, and then the C semicolon signifies the operation to select the system clipboard. And then we concatenate this with our buffer, and to define the end of an escape sequence for OSC 52, we can use escape backslash. And these details you don't need to know about. You just copy this stuff and it'll work. I'll link in the slides more details about operating system commands. There's not many good resources on them, unfortunately. So next thing I'm going to do is I'm going to silently execute a final command to pass whatever I have defined here in my buffer into the TTY for it to, into the Vim control TTY to synchronize with my local terminal. So to do that, I run an execute and I do an echo that passes in the shell escaped buffer, and I can use a backslash to do another line, and I will pass that or pipe that into the shell escaped TTY. So on OS X, this is usually /dev/TTY, which signifies the current process is TTY. I'll show you an even better way to do this in a second, but let's just bear with me here. So that's my function. Let me double check that there's no errors. So again, what I'm doing here, I copy something in my register, I base64 encode it because it has to be base64 encoded. I then make the buffer start with the OSC52 start escape sequence, and then signify to select the system clipboard, then put the yank contents in, and then end it with whatever the escape sequence has to end with. And then I want to pipe that into my terminal's Vim's TTY. And that's the function. And the beauty of OSC52 is once you do this, you're done forever. You don't have to deal with like piping a PB copy over SSH, for example, which is what I actually tried a long time ago. And this just works so seamlessly. Anyway, now I'm going to define an auto group that does this yank function automatically whenever I invoke a yank. And unfortunately, this part, this event, the text yank post, is only available in Vim 8 Plus. So if you don't have Vim 8 Plus, I think that's the version, then this won't work. But the function still works. So you can figure out another auto command to do something similar, or another auto command event, or just, yank it to your system clipboard whenever you invoke a certain mapping that does call the above function. But anyway, here I'm saying if on any yanking, if the actual event operator exactly equaled the yank operator, then I want to call this function, which is OSC52 yank. And that's the end of my if. And that's it. And if you don't know what auto group is, basically a best practice whenever you're defining a bunch of auto commands is to put them in an auto group. Otherwise, the auto commands will not get rewritten. So if you source it a bunch of times, you'll have like 100 auto commands, versus if you put it in an auto group and you source it 100 times, there will only ever be one auto command. That's what this line does, which I just realized I have a typo for. So let me just double check again that everything looks good, because hopefully I can again show all of this live. I think it looks good to me. So now if I just source this file and if I yank, I'm about to paste from my clipboard, by the way, not the actual Vim register. Guess what? That just got pasted. And again, I kind of touched on this on the last talk, but I think this is absolutely amazing. I mean, this is so useful if it's an SSH session, for example. Again, I'm pasting from my local clipboard here. So another thing you can do is, I notice when I'm working on a lot of Linux boxes, dev/tty usually doesn't work. So a new thing I've been doing is I pass in a global variable that gets passed into Vim when you start it that defines the parent controlling TTY. If anyone can think of a better viable option, please let me know, but this is the best I've come up with since. So basically, instead of passing in the dev TTY directly, what I do is I define a global variable here called g:_tty, G for global. And then the way it works is I'll pass in the TTY variable while I open Vim. And unfortunately, sometimes these jobs have to be terminated, or you can just exit with the exclamation mark if you're running terminal mode somewhere. So what I do here is I basically create an alias that I define in my zshellrc file, and that alias will always pass into Vim this new global variable I defined. And what that means is I always set this option, and the escaping of quotations and apostrophes is really annoying here. Just trust me that this is the correct way to do it. And you can again copy this from my .files repo. Later on, I'll link that in the comments too. But basically, I define an alias here, which passes in my controlling TTY when I open up Vim. So if I now echo g::tty, you can see it knows what the TTY is. And now if I copy and paste from my actual clipboard, the local clipboard, it's pasted. So that's how that works, and that shows you how to create your own plugin. And hopefully that plugin will have changed your life. If not, that is very unfortunate because it changed mine. Next, pack. This is the last one we'll be covering. And remember in the beginning, I showed you that slide and I was all like, what the fuck does package mean? Why is that path so damn long? So now we're going to clarify what packages are. So hopefully you know what plugins are, right? They're just simple scripts containing X commands that get executed. Well, a package is a directory or set of directories that contains one or more plugins. And of course, at first you might be thinking, why the hell do I need that if I already have plugins, right? I'll explain to you why. Let's go back to that slide I showed you a while back. So remember that first, the way the plugin script works is we execute the runtime on all Vim files in the plugin directory. And hopefully now this makes sense, right? Remember, like when we're dealing with runtime files, the context matters. In this case, plugins specifically are the ones that are always automatically loaded on Vim's initialization, which is why I put them as the second step when you open up Vim or open a file in Vim. So hopefully this first line now makes sense to you. And usually, again, as you know, this is in the user runtime directory path under plugin. And then after that, packages are loaded. And the directory path this is whatever I highlighted here. So now the question is, why is it so long? Like, that is so long. It's just really long. But it makes sense once you understand it. And I'll explain how this works. So why have packages when I have plugins? So let's say your Vim looks like this. Your user-defined runtime directory. And now let's say you want to install plugin A, which comes with some documents too. I didn't showcase examples for all of the components, but documents is another one. And now let's say you want to install plugin B, which also comes with some documents. Okay, you put another Vim file in plugin and another text file in doc. And now let's say you want to install an even larger collection of correlated settings C, and this one includes an autoload script as well as a plugin script and a doc. Do you kind of see the issue here now? There's a few problems with this approach that makes it very hard to manage all your plugins. Number one, they cannot be independently managed. Number two, there's no mechanism of marking a package as optional. So one thing I forgot to explain earlier was this notion of packages or scripts being optionally loaded. But Autoload is a great example of that. Autoload, you don't need to actually invoke until you need the function that's being called. Similarly, we can treat packages the same way. If I have a correlated group of scripts that I want to be loaded optionally, it would be great if I could have a way of defining that instead of always loading all the plugins or always loading all the plugins related to that package except the one in Autoload, if that makes sense. But anyway, it's mainly the first point that's important, I think. And that's that they can't be managed easily, independently. And then updating packages, it becomes a pain in the ass, right? Because how do you know which one is where? So that's why packages come to the rescue. And this is how it works. This is a pretty good visualization of things, hopefully. And what I highlighted in yellow are the package-specific details. So basically, in addition to all the folders we kind of glimpsed over so far, there's an additional one called pack. And inside pack, you can put collections of plugins or packages into separate directories so that they can be managed independently. And the way it works is inside pack, you define an arbitrary subdirectory. This can be named anything. It can be named McDonald's. It doesn't matter. And then after that, in your start folder, there's two main folders in this. There's a start and OPT. Let's ignore OPT for a while. Basically, in this .vim/pack/plugin/start, you can now create a separate directory for each package you want to independently manage. So for example, remember I had A, B, and C, right? So you can put A in start. And then A has its own same runtime path, directory-based configuration options, and it's all for A. There's no overlap here with B or C. Same happens for B, same happens for C. And this is nice because now we know if we want to update A, there's only A's stuff in A. Similarly, there's only B stuff in B. And then finally, this OPT is the second main type of package type you can put in. And these are packages that are not loaded automatically on start, but you can optionally load them by invoking the pack add command. So this might be useful if, say, you don't want to actually load a bunch of packages, configurations, unless you really need it, because the package itself has so many different scripts, not just the ones in Autoload. So that's how packages work. And the advantages are, as I just described, you can manage each of these independently. That's all Gucci. So let's show you one last example. And this last example, let's say we want to load some external packages. So let's say we wanted to discover a new plugin to use. I like Surround Vim by Tim Pope. which is really great because it allows you to automatically surround pieces of text with parentheses, brackets, etc., etc. So what I can do is I can just copy this directory. And now if I open Vim or I go to the Vim user runtime, what I can do is I can define a new package path. And remember, it starts with pack, and then any name you want. I'll call it plugins. And then start. And that should be, I mean, even I forget the path. Honestly, even I forgot the path already. It really is too long. Oh, right, I had it here. So Vim, pack, plugin, start. Yeah, that looks good. Okay, so in here, like let's say you want to add a new package. All you have to do is git clone in this repository. Oh, I forgot the CD into there. So all you have to do is git clone into here. And guess what? Vim surround should already be working. And I can surround my text with quotation marks. It's a great plugin. I highly recommend it, even though I don't recommend plugins that often. But anyway, you can see how easy that was, right? All you had to do is literally add a plugin to this directory. That would have showed this nicer, but anyway, that was it. One more thing. On portability, a lot of people sometimes think, Vim isn't that portable. What if I'm working on a lot of boxes? How do I keep everything in sync? I highly recommend something called GNU Stow. And basically, GNU Stow is a symlink farmer. And what that means is if you define a repository with a particular structure, and you have a repository that defines that structure for you, it will automatically get symlinked so that all the different configuration files are as you want them to be relative to your home directory, for example. And it's hard to explain this without showing it to you. So let me show it to you. So I'm just going to SSH into a random Linux box I have. And this Linux box, it doesn't have any vimrc or anything. Sorry, it doesn't have a vimrc. It has no Vim configurations. But I'm going to open or clone a directory which does. So I'm going to clone my my .files directory, which by the way does not yet have like super idiomatic Vim script, so it might not accurately reflect everything I've said here. I'm going to update that ASAP. Anyway, I'm going to clone that. Obviously, I forgot the name of my own repository somehow. Oh, right, it doesn't have my name. So I'm going to clone that. And now I'm going to go into that. And note that it has a particular structure. Specifically, I have a directory for each set of configurations I usually want to symlink to when using new machines. And what I mean by this is if I go into the Vim folder, which defines my Vim configurations, the directory structure reflects how I want to actually have my configurations placed when I'm actually loading to a new machine. Specifically in my Vim folder, you can think of everything here as being relative to the home directory, right? The first level relative to home is your .vim, and then you have all your different components. And then you have your .vimrc also at the top level of the home. So basically, with GNU Stow, when I have this directory structure, and I say to stow whatever I have in the main .files repository, it will create symlinks relative to whatever I just showed you. So again, I don't think it'll make sense. It took me a while to understand this, but watch this. Let me just install it really quickly. Oops. Install it, not remove it. And now I have GNU Stow. And now, for each directory I want to stow, I'll just do vim for now. I just type stow vim. You know what just happened? Watch. I go to my home directory and I do an ls. Look at that. Now my vimrc links exactly to the file I defined in my actual repository. So these are all symlinks, which means whenever I actually edit my vimrc, it's going into my .files repository. Now the reason these were also linked is because I think I did it earlier, or maybe by default stow does even directories you don't specify. I think it's because I did it earlier. But anyway, the point here is that this is a super powerful tool for portability. And then a final question people sometimes ask is, what about external plugins? And basically the way I work with that is I go to my .files repository and I define a submodules folder. And in this submodules folder, I add all my Git submodules, using Git submodule add. And then to refer to them when using Vim, what I do is I go to my .vim folder under pack and start. And in this folder, everything you see is another symlink to the actual submodules. And when you combine this with GNU Stow, everything is super portable. So whenever I have a new box, I just git clone and I run stow and I'm done. Nothing else to do. So that was on portability. And with that, the presentation is over. I hope that was really informative. Please give me any feedback you want. Talk to me about future topics you might want me to cover. In the future, I'm not just going to cover Vim, by the way. I'm going to do all sorts of topics, mainly focused on tech, because I love teaching this kind of stuff. If you have any questions, email me, follow me on Instagram, Twitter, whatever. Also, please remember to subscribe so I can keep this channel going. And thank you so much for watching this presentation. Stay tuned for more, because there's going to be a lot more coming.